Question 8, part 1 says the random variable x has the following probability distribution. Now we need to find the probability that x is greater than 1 given that we know that x is less than or equal to 3. Now there's a couple of ways that you can approach this. Because it's conditional probability, you might want to think about going straight for a formula. Now we know the conditional probability formula says the probability of A given B is the probability of A and B over the probability of B. And this formula can be quite helpful for just framing our thinking. Now, first you need to define what A and B are. Obviously here A is x being greater than 1 and B is x being less than or equal to 3. So how can you have A and B at the same time? Well, you'd have to be greater than 1 but not equal to it, and less than or equal to 3. So at the top of our fraction here, the probability of A and B, well, here we've got probabilities of x being greater than 1, so we'd want this one and this one added together because it says less than or equal to 3, so it could be this or it could be this, not this one. So we need to add these two probabilities together, 0.4 plus 0.2, which gives us 0.6 on the top, over the probability of B. Now remember, B is x being less than or equal to 3. So what's the probability of that happening? Well, less than or equal to 3 are all of these outcomes here added together. So it's everything except this one, which is 0.1. So obviously these all add up to 0.9. Now we just need to simplify the fraction. 0.6 over 0.9 is the same as 6 over 9, which is the same as 2/3. Now part 2 says to find the variance of x. Now you've got the choice of formula 1 and formula 2. You need to add some more rows and some more columns here. We're going to need the sum, no matter which formula we use. Now when you're trying to decide which one to use, I try to wait until I've actually got the expected value to decide. Because if the expected value is a whole number and my actual outcomes are whole numbers, formula 1 can be nice and quick and easy. But if the expected value is a fraction or a decimal, the calculations get a little bit complicated, and because these values of x are whole numbers, they're really nice and easy to square. So the second formula, or the alternate formula, is often easier. So I'll need a couple more rows here either way. First thing I need to find the expected value is each score multiplied by its probability. So 0 times 0.1, 1 lot of 0.2, 2 lots of 0.4, 3 lots of 0.2, and 4 lots of 0.1. Now obviously the probabilities all add to 1. We just check that, that's a checking row. But we need to add these up and it will give us our expected value. So 0.2 plus 0.8 is 1, and 0.6 plus 0.4 is another 1, so that comes to 2. Okay, it's a whole number, so I'm thinking formula 1 could actually be the easiest one to use here after all. So to use formula 1, I need to take each score away, take the mean away from each score, and then I need to square those. And then on the next line, I'll need to do those numbers multiplied by the probabilities, and then add those up, and that will give me the variance there all in one go. Okay, so I need to do each score minus 2. So 0 minus 2 is minus 2, and when I square that I get 4. 1 minus 2 is minus 1, and when I square that I get 1. 2 minus 2 is nothing, squared is 0. 3 minus 2 is 1, squared is 1. And 4 minus 2 is 2, and we square that, we get 4. Now I need to multiply each of these numbers by the probabilities. So 4 lots of 0.1, 1 lot of 0.2, 0 lots of anything is 0, 1 lot of 0.2, and 4 lots of 0.4. And now if I add these together, I've got 0.6 plus another 0.6, I get 1.2. So this is the variance, and the variance will be 1.2. Now if you'd used formula 2, you would get the same answer. We'll do it quickly just to show you. So you need to find each score squared and then multiply that by the probabilities. So you can do that in 2 steps, put x squared here and then put x squared px on the one below, but I think it should be easy to do 2 things at once here. Square the 0, 0, times by anything is still 0. Square the 1 and you get 1, multiplied by 0.2 is 0.2. Square the 2 and you get 4, multiply that by 0.4 and we get 1.6. Square the 3 to get 9, multiplied by 0.2 is 1.8. Square the 4 to get 16 and multiply by 0.1 and we get 1.6. Now if I add these together, I've got, what have I got here? 2 plus 3.2, I've got 5.2. Now what do I do with that? Well, with the second formula, I take my 5.2 and I subtract the square of the mean, which is 2 squared. 5.2 minus 4 is still going to give me 1.2, exactly the same as when I use the other formula.